everything we thought we knew about humanity's first step to the top of the food chain just got turned upside down. And the truth is far more humbling than we ever imagined. For decades, scientists have painted a heroic picture of our ancient ancestors. The story goes like this. Approximately 2 million years ago in East Africa, early humans finally said enough is enough to the carnivores that had been making meals out of them. These prehistoric humans supposedly learned to fight back against their predators, became skilled at stealing fresh kills from big cats, and triumphantly claimed their spot as the new apex predators of their ecosystem. The star of this evolutionary success story? Homo habilis, a species that many anthropologists have long celebrated as the first truly human members of our family tree. But here's where it gets controversial. Groundbreaking new research is completely dismantling this narrative, and the implications are staggering. Homo habilis, it turns out, might have been nothing more than leopard food. Let's dive deeper into what made H. habilis so special in the first place. These ancient hominins weren't just another group of early human relatives stumbling around the African landscape. They were innovators who created what we now call the Oldowan toolkit, the earliest known stone tools discovered in Tanzania's famous Olduvai Gorge. This archaeological site has been absolutely crucial for understanding human evolution, and it's where researchers first found evidence that seemed to support the humans becoming predators theory. The evidence appeared compelling at first glance. Scientists discovered butchered animal carcasses that showed clear signs of hominin intervention. The logical conclusion? H. habilis had developed the intelligence and courage needed to confront dangerous carnivores, successfully steal their kills, and process the meat using their newly invented stone tools. This interpretation made perfect sense when compared to their predecessors. Earlier human relatives like Paranthropus and the various Australopithecine species were definitively known to have been regular prey for leopards, lions, and other massive cats. But this is the part most people miss. The assumption that H. habilis had broken free from this cycle of predation was based more on wishful thinking than solid evidence. Enter the game-changing research that's rewriting our understanding of early human survival. A team of scientists decided to take a fresh look at something that had been hiding in plain sight: the fossilized remains of 2 H. habilis individuals from Olduvai Gorge itself. One of these specimens is particularly significant because it's the 1.85 million-year-old holotype that scientists used to define what H. habilis actually looked like and how they lived. Both sets of remains showed clear evidence of having been chewed on by animals, but here's where previous interpretations went wrong. Earlier researchers had dismissed these bite marks as the work of scavenging hyenas, animals that would have come along after the hominins died from other causes and simply gnawed on the already dead bodies. This interpretation conveniently supported the narrative that H. habilis was too formidable to be actively hunted. However, the new research team wasn't satisfied with these assumptions. They deployed cutting-edge artificial intelligence technology to analyze the tooth marks with unprecedented precision. The results were shocking. The AI determined with greater than 90% probability that these bite marks came from leopards, not hyenas. More importantly, the pattern and location of the marks strongly suggested active predation rather than post-mortem scavenging. These weren't random accidents or isolated incidents. We're looking at 2 separate H. habilis individuals who met their end in the jaws of leopards. As lead researcher Manuel Dominguez Rodrigo explains, the implications are absolutely massive. If we considered these 2 individuals as representative examples of the broader H. habilis population that lived in the Olduvai region, their shared fate tells a troubling story. It suggests that this supposedly advanced human species was still completely vulnerable to predation by medium-sized carnivores like leopards, animals that a truly dominant species should have been able to either avoid or fight off successfully. The implications of this are major, since it shows that H. habilis was still more of a prey than a predator. The researchers write in their groundbreaking study. Dominguez Rodrigo puts it even more bluntly. It's kind of dethroning Homo habilis. For years, scientists have been depicting H. habilis as the first conqueror of the trophic pyramid, as the scavenger hunter fending carnivores off from their kills. But this new evidence reveals that these hominins were actually meeting the same grisly fate as their Australopithecine predecessors, being actively hunted and consumed by leopards. Rather than representing a revolutionary leap forward in human evolution, H. habilis appears to have remained stuck at the same vulnerable level in the food chain. This revelation raises a fascinating question that researchers are now scrambling to answer. If H. habilis wasn't humanity's first apex predator, then which of our ancestors actually earned that distinction? The most likely candidate, according to the research team, is Homo erectus, a species that existed around the same time frame as H. habilis, but had evolved some crucial differences. Unlike H. habilis, which still retained many tree-dwelling characteristics, H. erectus was much more adapted to ground-based living. This terrestrial lifestyle might have been the key advantage that allowed them to successfully confront and intimidate large carnivores. The researchers speculate that H. erectus possessed the physical capabilities and behavioral strategies necessary to fend off leopards and other dangerous predators. More importantly, they might have been the actual pioneers of the scavenging behavior that allowed early humans to steal fresh kills from big cats, the behavior that was previously attributed to H. habilis. But here's where things get really controversial. This research doesn't just challenge our understanding of one species, it forces us to reconsider the entire narrative of human evolutionary progress. We've long told ourselves a story about steady, inevitable advancement from helpless prey to dominant predator. What if that story is fundamentally wrong? What if the path to human dominance was far more circuitous, with multiple false starts and evolutionary dead ends? And this raises an even more provocative question. Are we giving our ancestors too much credit for their supposed evolutionary achievements? Maybe the development of stone tools and other early technologies wasn't enough to fundamentally change the survival equation. Maybe intelligence alone wasn't sufficient to overcome millions of years of predator-prey relationships. This study, published in the prestigious Annals of the New York Academy of Sciences, is already generating heated debate in the scientific community. Some researchers argue that 2 specimens isn't enough evidence to completely overturn decades of established theory. Others contend that this finding perfectly explains some puzzling gaps in the archaeological record that the traditional narrative couldn't account for. What do you think? Does this research fundamentally change how we should view early human evolution, or are we reading too much into limited evidence? Are we perhaps too eager to see our ancestors as successful predators when the reality might be that survival was much more precarious than we'd like to admit? And if H. habilis really was still leopard prey despite their tool-making abilities, what does that say about the relationship between intelligence and survival in the ancient world? Share your thoughts. Do you find this dethroning of H. habilis convincing, or do you think there might be alternative explanations for these leopard bite marks that the researchers haven't considered?